Students, in previous lecture we learned some topics from mathematical methods like scalars, vectors, types of vectors, then addition and subtraction of scalars and vectors, and law of parallelogram of vectors, law of triangle law of vectors. These are some topics we studied in our previous lecture. In today's lecture, we'll start with resolution of vectors, scalar product, and dot product of vectors. So we'll start resolution of vectors. Two or more vectors combined together and a resultant vector is produces. A definition of a resultant vector is a single vector which have same effect that of two or more than two vectors. We already studied the resultant vector. Now here resolution of vector, the process of splitting single vector into two or more than two components in any direction are known as resolution of vectors. Single vector is split into two or more than two components in any direction is a resolution vector. If the components of the vectors are perpendicular to each other, then the components are the rectangular components. We know them as a rectangular components. If the component of the vectors are perpendicular to each other, then that components are rectangular components. So rectangular components in two-dimension diagram, x-axis, y-axis, O is the origin, and r bar is a vector. It is denoted by OC. Then perpendiculars drawn from C, that is CA and CB on x-axis and y-axis respectively. Okay, R bar, OC bar is a vector in xy plane. Then as I said, perpendicular drawn from C on x-axis and y-axis as shown in the diagram. OA bar is RX bar and OB bar is RY bar. These are the components of R bar along x-axis and y-axis. Okay, are the components along x-axis and y-axis. By using law of parallelogram of vectors, we'll write resultant vector R bar is equal to Rx bar plus Ry bar. By using unit vectors, we'll write R bar Rx I bar plus Ry j bar. Rx and Ry are the components of R bar along x-axis and y-axis. Now, I bar and j bar are the unit vectors. I bar is along x-axis and j bar is along y-axis. These are the unit vectors, and definition of unit vectors we studied in our previous lecture. Now theta is the angle between r bar and OA bar. Then cos theta in triangle OAC, cos theta is Rx by R bar. Rx bar, R bar. Then Rx is equal to R cos theta. In same triangle, write sin theta, Ry bar by R. Then Ry is equal to R sin theta. Squaring and adding these two equations, we'll get r square cos square theta plus r square sin square theta. These are the right hand sides of the equations. Squaring and adding, then is equal to rx square plus ry square. Then on left hand side, r square is common, and into bracket cos square theta plus sin square theta. We know the identity. Cos square theta plus sin square theta is equal to 1. Therefore, our next step is r square is equal to rx square plus ry square. Then r is equal to square root of rx square plus ry square, taking square root on both the sides. This gives us the magnitude of the vector r bar in xy plane. Then direction of r bar, tan theta is ry by rx, and theta is equal to tan inverse of ry by rx. This gives the direction of r bar. We already studied in the law of parallelogram of vectors, way to find out the direction of a resultant vector. Now if the vector is in the Cartesian coordinate system, we know that in Cartesian coordinate system, three axes, x-axis, y-axis and z-axis, are mutually perpendicular to each other. If the vector is in the Cartesian coordinate system, then resultant vector r bar will write rx bar square root rx bar square plus ry bar square plus rz bar square. Magnitude we will find out same way, that is in two dimension, how we find the magnitude of the resultant vector. Same way we'll write here, r bar is equal to square root rx bar square plus ry bar square plus rz bar square. Okay, here if the vectors are equal, it means their corresponding components are also equal, and vice versa. Suppose a bar equal to b bar, then in Cartesian coordinate system, ax I bar ay j bar plus az k bar, that must be equal to bx I bar plus by j bar plus bz k bar. Then here definitely the components must be equal. We'll write uh, ax is equal to bx, ay is equal to by, and az is equal to bz. So this is about the resolution of vectors in 2 dimension and 3 dimension. Then multiplication of the vectors. In first lecture we already studied how we can add scalars and vectors. Okay, if we add vectors or subtract the vectors, we'll get a third vector, uh, resultant vector. Resultant vector is same that of the two or more than two vectors which is used for addition and subtraction of vectors. In multiplication of the vectors, if we multiply two vectors together, we'll get a third physical quantity. Okay, for example, force and displacement. Multiplication of these two quantities will get a third quantity, work. Now force is a vector quantity and uh, displacement is a scalar quantity. If we multiply to this, we will get a scalar quantity, that is work. Similarly, mass is a scalar quantity, acceleration is a vector quantity. If we multiply these two quantities, we will get third physical quantity, that is force. Force is a vector quantity. So we'll definitely say over here, if we multiply scalar with a scalar, third quantity will be always scalar. And if we multiply uh, scalar and vector together, we'll get third quantity as a scalar or a vector. There are the various examples in our syllabus, and definitely we'll learn time to time. Now multiplications of the vectors, and in this we have to learn scalar product of two vectors and vector product of two vectors. First we'll start with scalar product, that is dot product, and statement of scalar product is the scalar product or dot product of two non-zero vectors is defined as the product of magnitude of two vectors and cosine of angle between the two vectors. Uh, we'll go with the equation. Scalar product of p bar and q bar will be uh, p bar dot q bar is equal to pq cos theta. P and q is the magnitude of vector p bar and q bar respectively, and uh, cosine of angle between them as per the statement. So dot product of two vectors, that is p bar dot q bar, is equal to pq cos theta. Theta is the angle between the vectors p bar and q bar. Now characteristics of the scalar product diagram. Two vectors p bar and q bar inclined with angle theta, or you can say they are separated by angle theta. Then p cos theta is the component of vector p bar along the vector q. I repeat, p cos theta is the component of vector p bar along q. Here p bar q, vector q is this, and vector p is here. component of P bar is along Q as shown in the diagram. So according to the statement, P bar dot Q bar is equal to PQ cos theta. Then we'll write P into bracket Q cos theta. Uh, P component of Q in the direction of P bar is Q cos theta, and P bar dot Q bar is equal to Q P cos theta. From this, the first characteristic is the scalar product of two vectors is equivalent to the product of magnitude of one vector with the component of magnitude of component of the other vector in the direction of the first vector. Here P bar and Q bar are the two vectors, and dot product of these two vector is magnitude of first vector, that is P, and component of another vector, that is vector Q, in the direction of vector P has to be considered. So the first characteristic is scalar product of two vector is equivalent to the product of the magnitude of the first vector with the magnitude of the component of other vector in the direction of the first vector. Second is scalar product obeys the commutative laws of vector multiplication. Again, we have to consider the P dot Q bar is equal to PQ cos theta. Similarly, we'll write uh, Q bar dot P bar is equal to Q P cos theta. Okay. Uh, Here we'll write P bar dot Q bar is equal to PQ cos theta, and dot product of Q bar and P bar is QP cos theta. And these are the same. Therefore, we can write P bar dot Q bar is equal to Q bar dot P bar. So the scalar product obeys the commutative law. If theta is equal to 180 degree, now the angle between the vector is 180 degree, then P bar and Q bar are anti-parallel to them. Actually, if the angle is 180 in this diagram, if the angle is 180, then uh, theta is over here. Okay, theta is the angle between these two vectors, that is P bar and Q bar. And if it is 180 means a straight line angle is there, means vector P bar and Q bar opposite to each other. Okay, anti-parallel to each other. Then uh, this will write with what? P bar dot Q bar is equal to PQ cos of 180 degree. 180 degree cos 180 degree is minus 1. Cos 90 is 0. Cos 0 is 1, and cos 180 quadrant is changed and it becomes minus 1. So P bar dot Q bar definitely will write minus PQ. Okay, so they are anti-parallel. If theta is 90, definitely the two vectors will be perpendicular to each other along x-axis and along y-axis. Angle will be 90. So here we'll make a statement when two vectors are perpendicular to each other, then their dot product is 0. Or vice versa, you can say dot product of two vectors are 0 when they are perpendicular to each other. Anyhow, we have to keep it in our mind. When vectors are perpendicular to each other, their dot product is 0. Okay. Here a bar dot b bar, a bar dot c bar. A bar is non-zero vector. Then definitely we'll write a bar dot into bracket b bar minus c bar. It is simple arithmetic and this is equal to 0. It means that vector a bar and the vector b bar minus c bar, they must be perpendicular to each other. Okay, uh, definitely. Then dot product of unit vectors, uh, I bar dot I bar, Z bar dot Z bar, and K bar dot K bar is always equal to 1. It is very simple. Unit vectors, dot product of unit vectors with itself is 1. Why it is 1? According to the definition of unit vectors, magnitude of I bar, Z bar, and K bar is 1. And I bar dot I bar means vectors are along the same axis. They are parallel or direction is same and angle between them is 0. They are collinear vectors. And if the angle 0, theta 0, cos 0 is 1. Unit vectors magnitude is 1. Therefore the product will write I bar dot I bar is equal to 1. This has to be keep it in our mind. If dot products of different unit vectors I bar dot z bar hai, तो definitely we'll write 0 because cos theta or theta is 90, cos 90 is 0. Therefore I bar dot z bar uh, is equal to 0. Just now I said when the angle is 90 degree, then their dot product is 0 or vectors are perpendicular to each other. Definitely unit vectors, that is I bar and z bar, is along x-axis and y-axis. Axes are perpendicular to each other. Angle is 90. Definitely the dot product is 0. Then dot product with itself is the square of the magnitude of the vector. This is one more characteristic that we have to learn. Then next characteristic is scalar product of vector expressed in terms of rectangular components. This is the very important uh, characteristic. Now in Cartesian coordinate system, vector p bar is px I bar plus py z bar plus pz k bar. Just now we studied in resolution of vectors. If the vector is in Cartesian coordinate system, then we have to consider three components. So px is along x-axis, py is along z-axis, and py is along y-axis, and pz is along z-axis. I bar, z bar, and k bar are the unit vectors along x-axis, y-axis, and z-axis. So dot product of these two vectors in Cartesian coordinate system, we have to prove p bar dot q bar is equal to px qx plus py qy plus pz qz. Uh, so we'll write these two vectors, px I bar plus py z bar plus pz k bar, dot product with qx I bar qy z bar qz k bar. Now two brackets, and we know the multiplication of the brackets. First component, first term in first bracket multiplies to the second bracket, then second bracket from first, sorry, second term from first bracket multiplies to the second bracket. It is shown over here. Px I bar is the first component of first bracket, and it multiplies to the second bracket. Similarly, we'll write second component of first bracket to the second bracket, and third term is to the second bracket. So simple multiplication is there. Px and Qx are the uh, components, and I bar, J bar, K bar are the um, unit vectors along x-axis, y-axis, z-axis. So definitely product will write in this way. That is I bar dot I bar. Unit vectors product is in bracket, and Px Qx is the components. Their product is will write in this way. Okay. Here I bar J bar is equal to Px Qy. I bar dot K bar Px Qz. First component, first term, first bracket is multiplied to the second bracket. This multiplication is over here along with the unit vectors. Then second term of the first bracket multiplies to the second bracket. It gives us what? J bar dot I bar py qx, j bar dot j bar py qy, and j bar dot q bar k bar is equal to is py qz. Py is the component of vector p, and it multiplies to the second bracket. This multiplication is simple. We have to write unit vectors multiplication in bracket and components of the vectors separately. So now the third term pz k bar, here pz k bar multiplies to the second bracket here, uh, k bar dot I bar pz qx, k bar dot j bar pz qy, and k bar dot k bar pz qz. Then here uh, uh, characteristic of unit vectors, this identity or this characteristic has to be used over here. We know that I bar dot I bar, j bar dot j bar, and k bar dot k bar is equal to 1. So definitely uh, these terms, that is I bar dot I bar, j bar dot j bar, and k bar dot k bar will be 1. All other terms, that is I bar dot j bar, definitely it becomes 0. I bar dot k bar is equal to 0, because dot product with different unit vectors is equal to 0, because angle between them is 90 degree, cos 90 is 1. Okay, so next term becomes very easy. Here I mentioned that dot product with different unit vectors is always 0. If we use this in above step, then we'll get p bar dot q bar is equal to first line, that is this one. Here I bar dot I bar will be 1, and px qx is there. These two terms become 0. I bar dot j bar and I bar dot k bar is 0. Dot product of different unit vectors is 0. Therefore, this becomes 0 0 over here. Similarly, we will write in second line, that is py qy will be there. That is j bar dot j bar is 1. All other terms will become 0, and pz qz. So at final we write p bar dot q bar is px qx plus py qy plus pz qz. It is a very simple multiplication, and we have to keep it in our mind. That is, if the dot product of unit vectors with itself, then it is 1, and dot product of unit vectors with different unit vectors, dot product of unit vectors with different unit vectors, it is 0. So by using this, we'll solve this uh, product of the two vectors in Cartesian coordinate system. Now our next topic is vector product, and we'll say it is a cross product. Definitely the vector product or cross product of two non-zero vectors is defined as the product of magnitude of two vectors and the sine of angle between the two vectors. Actually, it is very easy to keep it in our mind. Uh, Dot product of two vectors, there is the cosine angle between the two vectors, and here we have to consider the sine angle between two vectors uh, when vector product has to be considered. Okay, so statement is definitely vector product of two vectors is the product of the magnitude of two vectors and sine of angle between them. Here additional one sentence is the direction of the uh, third vector or direction of the product of two vector is always perpendicular to the plane of the two vectors, and it gives with right hand rule, right hand screw law. Okay, so definition by diagram, p bar and q bar are the two vectors, they are in a plane, and the resultant is perpendicular to the plane of the two vectors p bar and q bar. uh, right hand rule, right hand screw law is if we rotate the vector p bar to q bar, then screw will be advances in forward direction. If we rotate the screw in clockwise, means p to q, then screw will be advances in forward direction. Okay, and if we rotate in anti-clockwise direction, that is q bar to p bar, then screw will be moved back. So this is a right hand screw law. Now the second diagram, vector rotates from q bar to p bar in this sense, this way. Okay, q bar to p bar means screw is in anti-clockwise direction, uh, screwdriver is anti-clockwise direction, and screw will be moved out. Here rotation is p bar to q bar in this way, p bar to q bar, clockwise direction. So this is a right hand screw law, and we have to use here in vector product to find the direction of the resultant vector or third vector. Okay, uh, r bar is equal to p bar cross q bar, so pq sine theta. uh, Here u r is the unit vector along the resultant, unit vector has to be considered, and here s bar is equal to q bar cross p bar, pq sine theta, u bar is the unit vector along s bar. So here, as I said, the explanation of the right hand rule is here. If a screw is rotated in the direction of p bar to q bar through a smaller angle, then direction in which the tip is advances is the direction of q bar, r bar, and it is perpendicular to the plane of the vectors, that is p bar and q bar. So this already we explained, and next we'll go to the characteristic of here we have to consider it is vector product instead of the scalar product. Vector product does not obey the law of commutative of the vector multiplication. P bar cross q bar definitely not equals to q bar cross p bar. because direction is change. So definitely we'll write P bar cross Q bar is equal to minus Q bar cross P bar. And if we consider the magnitude, this must be equal to each other, but direction of the cross products, if we change the um, place, means in law of commutative is not uh, obey over here. Simple way, magnitude is equals. Now magnitude is same and direction is opposite. Vector product obeys the distributive law of multiplication of the vectors. A bar is a vector and multiplication of this is with B bar plus Q bar. Definitely we'll write A bar cross B bar and plus A bar cross C bar. This is the distributive property of the vector multiplication, and this proves over here. Then uh, cross product, that is P bar dot Q bar is PQ sine of theta. Okay. Uh, Magnitude of the product of the two vectors and sine of angle between them according to the statement of the cross product. If it is 0, theta is 0, so definitely uh, P bar cross Q bar is equal to 0. This means what? Two non-zero vectors are parallel to each other. Their vector product is 0. Uh, in cross product, if theta is 0, then they are uh, parallel to each other. Is it? Uh, if theta is 180, then vectors are anti-parallel to each other. Okay, 180, then vectors are anti-parallel, and when it is 90, then vector perpendicular to each other, but their magnitude is not 0. Okay. In vector product, if the vectors are perpendicular to each other, their magnitude is not 1. Uh, it is not 0, it is 1. Magnitude of the vector product is equal to the product of the magnitude of two vectors. So this already we studied in the scalar product. Uh, okay, here we have to keep it in our mind, that is cross product of two vector is not a 0. Why it is not 0? When the vectors are perpendicular to each other, the angle is 90, sine 90 is 1. So uh, magnitude of these two vectors, that is P and Q, and into 1. So this becomes PQ. It has not become 0. So cross product of two vectors when they are perpendicular to each other, it is not 0. We have to mention here. Okay. Then uh, cross product of the unit vector is cyclic. I bar cross j bar is k bar, and j bar cross k bar is equal to I bar, and k bar cross I bar is equal to j bar. Cyclic, uh, this cross product of unit vectors with uh, this rotation, I bar j bar, next vector is j bar, in anti-clockwise, we'll get a third vector k. It is positive. If it is in anti-clockwise direction, the rotation of the vectors, that is I bar j bar, will get a third vector k bar is equal to third vector k bar. If it is in clockwise direction, definitely it is not uh, like this. If we change the direction of the rotation of the vectors, that is z bar cross I bar, we know that when uh, um, this vector sorry cross product is not commutative, if we change uh, the vectors, that is z bar cross I bar, this becomes minus k bar. K bar cross z bar is minus I bar, and I bar cross k bar is equal to z bar. Means if and clockwise direction, if we'll have the cross product of unit vectors, we'll get the third vector negative. Okay, and I bar cross I bar, z bar cross z bar, k bar cross k bar is equal to 0. Is it? So cross product with itself of unit vectors is 0 here in cross product. Okay, then the property with Cartesian coordinate system. Now p bar is in Cartesian coordinate system, so we'll write vector p bar px I bar py z bar plus pz k bar. One more vector, that is q bar is equal to qx I bar plus qx z bar plus qz k bar. Now again cross product means we have to take the multiplication of the two brackets. First term from first bracket multiplies to the second bracket, like that we studied in scalar product. No need to explain here once again. Now direct the product of first term from the first bracket to the second bracket is px qx I bar cross I bar, px qy z bar cross sorry I bar cross z bar, and px qz I bar cross k bar. First term of the first bracket multiplies to the second, then second term, that is py z bar, multiplies to the second bracket. We'll write this way, that is py qz z bar cross I bar, py qy z bar cross z bar, and py qz z bar cross k bar. Now the third term is pz q bar, multiplies to the second bracket, and this gives us what, pz qx k bar cross I bar, and pz qy k bar cross j bar, pz qz k bar cross q bar. Definitely dot product sorry cross product with the same unit vectors is 0. These three terms, that is px qx I cross I bar cross I bar, and py qy z bar cross z bar, pz qz k bar cross k bar, this becomes 0. Okay, and remaining terms, that is second term third term, here first term third term, and here first term second term, these terms has to be considered according to the multiplication of the unit vectors, and we have to consider this, that is I bar cross I bar, j bar cross j bar, k bar cross k bar is 0. Therefore these diagonal terms, okay, these three terms will be 0, and remaining 6 terms will consider according to this, that is I bar cross I bar hai, तो we'll write k bar, j bar cross k bar is I bar, and k bar cross I bar is j bar. Means here I bar cross j bar hai, तो we'll write k bar, px qy k bar. Okay, and here I bar cross k bar hai, तो definitely rotation is changed. We have to write minus j bar. So next term is according to this multiplication of the unit vectors. So we'll write first term, uh, first line, this one is 0, and here I bar cross j bar is k bar, and px qz as it is, but I cross j I cross k is j bar. Okay, now next over here, this one. Okay, j bar cross I bar, it is k bar. Okay, and second term 0, and we'll write over here. Here minus j bar, this term becomes minus px qz is j bar. Okay, like that we have to replace the unit vectors according to the cross product of the unit vectors. Okay, and we have to use this for write the property. Then the third one is this term is becomes minus, because k bar cross j bar is minus I bar, and here k bar cross I bar is j bar. Now similar unit vectors together means here I bar px qz I bar is flux, and next is over here pz qy. Okay, here py qz, here pz qy, these terms together. So we'll write p bar cross q bar is equal to this one, that is py qz minus pz qy, and I bar is the common, so outside the bracket. Similarly, we collect another term, that is pz qx and px qz, and j bar is the unit vector. Here this one pz qx j bar and px qz j bar, these terms together, j bar is the unit vector, common unit vector. And the third one is these terms together. Okay, uh, p uh, k, here px qy k bar, and here px py qx k bar, these terms together. Okay, so we'll write p x qy and py qx, k bar is the unit vector common. So this we'll write in determinant form, and we'll write this way: p bar cross q bar is equal to I cap j cap k cap, or you can say I bar j bar k bar unit vectors, px py pz components of the vector p in the Cartesian coordinate system, and qx qy and qz components of vector q in Cartesian coordinate system. If we solve the determinant, or using the determinant, if you use the determinant property over here, we'll get the same statement, this, that is p bar cross q bar is equal to this one. Okay, so this is the determinant property, and using cross product we have to solve it. Now the last part of this chapter, or one more characteristic, is area of the parallelogram. Here parallelogram OACB, and perpendicular is OD. Okay, now two vectors, that is P bar OA bar and Q bar is OB bar. Okay, uh, two vectors of the or it the sides of the parallelogram. Then P bar and Q bar are inclined at an angle theta. Okay, perpendicular is BD. H is the length, it is uh, as shown in the diagram. Okay, so area of parallelogram will write base into height. Base is OA and height is BD. Okay, साइन ऑफ थीटा लेते हैं, in this right angle triangle, that is OBD. Okay, this becomes BD by OB, BD by OB. So BD is equal to OB sin theta. OB is H, so we'll write uh, OB is Q. OB is Q, so we'll write PQ sin theta. So this gives the definition of the cross product, that is P bar cross Q bar is equal to PQ sin theta. So this is one important characteristic of the cross product. So we have to stop here and we complete uh, the topics which included in our syllabus. Okay, next part of the chapter, uh, differential calculus, is not included in for this year in our syllabus. So we'll stop here and next time we'll go with the problems of this chapter. Thank you.